Great. So now we've covered some of the basics of vector symbolic algebras, and next we're going to move on to examples of learning and generalization that we can get out of these neurosymbolic methods. It's important to know how learning happens in vector symbolic algebras. Typically, in a neural network, learning happens by modifying the synaptic weights. This is what backpropagation is for. With vector symbolic algebras, we have neural networks that we've specifically structured to implement the circuits that execute the algorithms that we specify using these algebraic statements. Learning can then happen in the activities of neural populations instead of the synaptic weights. And so we can have a population of neurons that would, say, represent the binding together of inputs, or it can accumulate memories in a bundle. And in theory, neural networks structured in this way can adapt quickly. And they don't necessarily need to worry about the weight transport problem, which is a big problem for biological circuits. Although, as we'll see later, these representations are still compatible with more standard gradient-based methods. Let's start first by looking at an analogy, and we're going to talk about the specific analogy king is to queen as prince is to blank. And we're going to show how to solve this using a vector symbolic algebra. You may be familiar with the sort of word-to-vec approach, where these components of a concept like king are structured through addition, or what in our case would be bundling. So you would have a king equal to ruler plus male, a queen is ruler plus female. And so if we subtract out male and add female, we will move from king to queen. And if we want to move from prince to the answer of the analogy, we do the analogous operation. However, we can also represent these using the binding operation. Representing as a king is someone who is a ruler and male, a queen is a ruler and female. And so what we'll do now in the next experiment is show how we can use this binding operation to figure out the analogy between a prince and something else.